Welcome back to our fluid simulation series, where we try to develop a two-dimensional fluid simulator like this one right here. Currently we are at a stage where we have some code that simulates a two-dimensional grid, and we can draw into that grid like this. And by pressing the space key, we can basically switch the type of cell we're drawing to simulate a fluid. So far we can draw walls or solids, and we can draw fluids. But as you can see right here, they are not animated yet. So we have to implement some logic here. And this is going to be probably the heart of the project, what we're going to do today. So let's open the source code. And here's what it looks like. Let me just save it and do a sample compilation command. That should be that. Okay, it still compiles, everything is fine. And yeah, right now, what we're doing right here, so this is the interesting part right now, is we're drawing a cell first of all, if the mouse is moving and the state of the mouse is not 0, that means that a button is pressed. So whenever a button is pressed, we're drawing a cell. However, we actually want to simulate fluids, so what we actually care about is not drawing cells. We want to manipulate cells that already exist. So yeah, so far we have a drawing program, but it needs some kind of model. It needs some backend to model the entire simulation. And to do that, we need to place our cells into a grid. We need to model the entire problem. So to do that, I would suggest, after drawing the grid, we have to model the cell grid here. And then once it is modeled, we can draw the entire cell grid. And then using the mouse clicks, we manipulate the cell grid itself. And then after that, we draw the entire cell grid. So we don't draw by mouse, but we manipulate the model by mouse. That's a slight but important difference. Yeah, so we're going to create, I think, an array of cells, a struct cell, and that is going to be let's call it the environment. And that is an array of cells of size, where we need to know how many cells there are. How many cells are there? We have the cell size here, the screen width and the screen height, so the cell count derives from that. We also have the rows and columns. Yeah, I forgot. Yeah, right. Oops. Right there. So okay, we have a cell array that is of size rows by columns. That is the size of the array. And then we initialize this environment. And to do that, we can just call a function, initialize environment, and we pass the environment by reference. Environment, like that. And of course, we need to first implement that function right here. So I'll copy this method signature, and then let's put it right here. Void initialize function. We receive what do we receive? We receive a cell pointer. No, we receive actually a cell array. No, we can just do struct cell array, and any manipulations on the array should reflect in the array, so that we don't need to pass a pointer, I think. Or we don't need to pass the address. Well, okay. Let's see. Let's just try it out and see what happens. And I think my definition here in the signature is wrong. I need to put the brackets here, and then also I can provide the size rows by columns. And then in initialize environment, I can remove the ampersand sign because I don't want to pass the address. I can just pass the entire array. And then I can just loop over all the arrays, over all the elements, all the cells in the array. And then for each cell, we're going to, since we initialize it, we set the environment at that index to be equal to a new cell. So we create a new cell right here. So we do this struct cell, and then we pass the parameters. So we have a type, a fill level, X and Y. Okay, type is, we defined a constant before. What was it? There's a water type and a solid type. This means that we can just, well, when we initialize the environment, every cell should be water type. But of course, not every cell should be filled with water. So we do a water type. Water is practically every cell. But as long as we don't set cells using the mouse, I would like the cell to be empty. So it's an empty water cell. I think that would be a solid model. So let's just have a look. So there's the water type here. Then in our struct definition, then next comes the fill level. Maybe we should change this to be a double. Just to be able to be more precise when calculating things. I note that whenever we work with fractions in C, using integers usually leads to bugs that are annoying to fix and find out later. Maybe we have just introduced a new bug by changing the integer to a double, but yeah, we will have to figure that out later. So we have the water type, we have the fill level, which is 0 for now, and then the X and Y are, how do we determine X and Y right here? Because we're just looping over the simple one-dimensional array. I think we need to do a nested loop. First we loop over the rows, then we loop over the columns for int j equals 0, j smaller than columns, j++, and then we're going to do this. And the x coordinate is now the column number, so it's j, and the y coordinate is the Right, good question. What is the y coordinate? coordinate now. It should be the row count, right? I am not yet sure. Yeah. Okay, I was thinking that we're missing something. Yeah, right, because here in the environment we're accessing index I, but we have to access index j plus columns multiplied by I. Maybe if you don't know this syntax, please stop the video and think about it for a minute. But pretty much, oh no, maybe let's just explain. Let me explain it. We have a, come on. So we are dealing with a two-dimensional grid. So this is our application now. Okay. However, all the data, all the cells, this cell and this cell and this cell, etc., they are going to be modeled in a one-dimensional array, just because it's simple in C. 2D arrays are always a bit annoying, so I would like to model this entire grid in a one-dimensional array. So this is one long block of data. Now the first cells in the first row are going to be these right here. Then the cells in the second row are going to be these right here. And that is, and it goes on like that. And that is why when we determine which index to write into the array, for example, we would like to write this yellow cell right here. This is column number 3 plus the row number, which is the first row, multiplied by the number of columns. So we count all the columns, then we know it's one row, so we multiply that. One row times 4 columns in this case, plus 3 columns. And that's what we're doing here. So we count the rows and columns together, plus the number of columns, or plus the column index, I mean. Yeah. If that was a bad explanation, then sorry. This took me a while to figure out, but I've seen other people online do this as well. So it's a common practice. This way you can manipulate and model 2D data using a one-dimensional array, which often makes things a bit more simple, especially if you don't know C too well and you don't want to deal with arrays of arrays and pointers of pointers and all this kind of stuff over and over again. So did I mess something up? Yes, I messed something up, and that is in initialize environment. In the first call, I forgot the semicolon. So that should now be working. We have now an initialized environment here, which is a good thing. And what is missing? Now that we have initialized the environment, we should still have the same core functionality in our application. So nothing has changed. Yeah, we still draw everything manually, and we still have the same drawing capabilities because we are drawing the cells here, but we're not placing the cells into the environment, and we need that in order to calculate the simulation. The simulation does not work on pure graphics. We have to create a backend for the simulation. So instead of drawing the cell here, when we register a mouse event, we need to create a cell And then we have to place that cell into the environment. So here we determined the cells X and Y. And based off that, we should be able to set that cell in the environment. So let's try that. Environment. And then we access the index that is going to be the cell. And pretty much we have the same access pattern here. I hope it works, but this should be this pattern. So we access the cell Y and X coordinate in the one-dimensional array, and then we place the new cell there. Actually, we don't have to place a new cell. We could also read the cell from the environment and just manipulate the fill value of the cell or the type of the cell. Maybe that's something we should do later, but let's just keep it like that for now. And then instead of drawing the cell, we don't draw the cell, we just set the environment, and then we draw the entire grid down here. Draw the entire environment. And then we pass on the environment. Okay, and now we need to create a method that is going to be called draw environment, void draw environment, and it's going to take as input an STL surface, and then of course the environment pointer or environment array, environment, and that is of size rows by columns. I think at this point we don't need to specify the size, because here the size is implicit, or should be implicitly available to the compiler. But in general, it makes sense to just specify if the size is known. Why not just specify it? Okay, so now that we draw the entire environment, what we can do is we can reuse the draw cell, this function right here, and we can just call it in a loop. So for every cell, for every environment index that is part of rows by columns, we call the draw cell function. We pass the surface and we pass the environment at index I. So now we're just passing index I because, wait, let me fix the for loop for a second. And that as well. And that as well. Oh man, I put so many syntax errors this time. Okay, so now we don't have to do any special kind of array accessing, because here we're just accessing every element of the array. We don't care about the coordinates. The coordinates are stored inside the cell. So here we are getting all the cells, and we're calling draw cell on all the cells. We don't care about coordinates at this point. And further down right here, where we place individual cells inside of the grid, we need to care about coordinates. So that's why we have to specify using this pattern. Yeah. Okay, so here we draw the environment to the surface. I forgot passing the surface. And now there should not be an error. Let's try to compile it. And the compilation worked. Okay, yeah, that's what I expected. Or no, I didn't expect it, but it is natural now. We initialize the environment in the initialize environment call in this one, and we set every cell to water type, and we set the fill level to 0. However, now that every cell is a water type, everything is going to be blue because we don't differentiate the cells look based on the fill level. So here, if the cell is water type, the color is going to be blue, even if the cell is going to be empty. So either we could somehow, well, now the question for me is, how do we determine, or how do we visualize the fill level? Either we could draw the cell and then make it half full, for example, for 50% fill level. However, yeah, no, that would be completely valid. And alternatively, you could also do an interpolation between the black and the blue color. So a full cell is going to be bright blue, and an empty cell is going to be closer to black, so it's going to get darker. But if we interpolate the colors, then probably the simulation will look like gas, and depending on fill levels, something is brighter and darker, so things are going to look smooth. And actually, in reality, water has a clear surface. Water is a distinct body of something. So I would prefer the drawing or visualizing the actual fill level of the cell. So let's try to do that. So if a cell, wait, let me draw it here. So this is one cell. Let me write fill here. And if the fill level is 50%, I would like to make it look like this. So it's 50% empty, 50% full. Let me just also write that, just so that it's clear later on. Okay. To do that, how do we do that? So technically, we could make every cell a base color of black. And then we need a second rectangle to, according to the fill level. So the default color should be color black. I hope I don't mess up something now. Then if the cell type is water type, we need to check the fill level. Oh, this is tricky now. So how do we determine from the fill level the number of pixels? For example, this is pixel 0, this is pixel 20. How do we know that this is 10? 10 pixel. And then from 0 to 10 pixels we draw black, for example, or the other way around. Okay, we probably need a new variable that is empty pixels, and that is equal to the cell's fill level, cell.fill level, divided by, can I document here that the fill level is a number between 0 and 100, so we know it's a percentage. The cell's fill level divide, or should we do 0 and 1? Zero and 1 might be a bit easier for calculations. Between 0 empty and 1 full. Okay. So the cell's fill level multiplied in this case. If we have a 20% fill level, then empty pixels are going to be we could do 1 minus cell.fill level. That is effectively the level of the void, of the emptiness. And then we multiply that by the cell size. This should be the height of the empty pixels. So let's draw the rectangle for that. STL rect empty. I don't really like drawing the empty pixels. Maybe we should draw the water height. Water height. Yeah, that is probably easier, at least for this calculation, for this line of code. And water, let's draw a water rectangle. And that is going to be an STL rectangle that starts at, what is the x coordinate of that rectangle? It's going to be pixel x should stay the same. Now pixel y might be a bit different. Pixel y. This is confusing. So this right here. This right here is y. This corner, and this is x. Then this is the width of the cell and of the rectangle, and this is the height of the rectangle. Now we have to offset the y to here. By the size of the void. Void offset. Yeah, then that's a bit annoying. So we actually do need the size of the void. Let me call it, or empty height is equal to cell size minus water height, and so pixel y is going to be offset by empty height no, y is going to be the same, but we're going to draw the height then based off that. So width is also same, but then we can provide the empty height here. Yeah, maybe this is okay. So we have now a water rectangle. I don't know if it's defined properly. No idea. No, this is not properly defined. This is the water rectangle. It starts at y plus the empty height, yeah? And it has a height of water height. And then we also need a background rectangle that is going to be this cell rectangle probably. So let me call this background. No. This can stay cell rectangle. So cell rectangle, color black. Then now we have a water rectangle that reflects the fill level. Then we pass on a color. And in fill rectangle, we draw the rectangle, the cell rectangle, but on top of that, we need to yeah, we first draw the cell rectangle, which is basically the background. And if we have a water type cell, we draw the fill level on top of that. Then the color is going to be blue, and we're going to call fill rectangle on the surface. We're going to call a water rectangle on using the color blue. Let me just pass the color in here directly. Color blue. And here we can pass color black directly. So if the cell type is water, we're going to fill this. And if the cell type is if the cell type is solid type, then what we're doing is we're going to just fill a rectangle, the regular cell rectangle, which is the entire cell, and we're going to do color white. So this is practically the background color. I will document this here. Background color. Then this is the water fill level. And this is solid blocks. It compiles. Let's see what happens if I execute this. Okay, somehow the grid vanished. Let's see where the grid went. Here's draw grid. Probably we need to draw the grid after drawing the environment, because it's going to be drawn on top of the cells. Okay, the grid is back, so that is correct. Now we can still draw cell. No, something is. No, is it working? It's not really smoothly working. Somehow something is weird. Segmentation fault. I get a segmentation fault. Or am I? Yeah, segmentation fault. So I coded a serious bug. Let's try to find out what's going on using GDB. We can do GDB fluid. No debugging symbols found. Let's see if we can still find out at least where the segmentation fault is. So I'm just drawing things right here. Okay, there's no message about the segmentation fault. I think we need to add the compilation flag G. Let's see if we can now find out where the segmentation fault is. Oh, it's behaving really weirdly. Okay, now I get a message. Let me quit this. Now I get a message at fluid C line 110, and this right here is the issue. Okay. I wouldn't have expected this line. So let me enable the line numbers and go to line 110. It is this line right here. in the environment, cell X and cell Y are equal to the new cell. Maybe a problem is that we define the coordinates of the cell once through the index of the environment, of the index of the cell within the environment, and then also again in the cell. So this is somehow a weakness in the model. Can we just have cells without X and Y? Does this make sense? Yeah, a cell should just be a type and a fill level. Does it inherently have coordinates? I don't know. Depends on how you model the problem. And that is always the core of a proper simulation. It shouldn't be a problem as long as the environment index is aligned with cell X and cell Y. Let me just add a printf here. Printf, writing cell at X equals this and Y equals that. New line, don't forget that. I forget it way too often. Not this time. Then I will pass on cell X and cell Y. Let's see where we get the segmentation fault. Okay, we get a lot of calls right here. A ton of calls actually, but we don't see that many cells refreshing on the screen, so something is wrong there. I think we have to remove the cell X and cell Y from the cell itself. Maybe that's not proper modeling. And then we can see if we still have the problem, and if we still have it, at least we still have the problem and have fixed a bit of the design and the modeling. So a cell does not have an X and a Y coordinate anymore, but it is placed into the environment at an X and a Y coordinate. Oh, and wait, let me just revert the changes. Maybe I have to change this to cell Y, no, to cell X and cell Y. Maybe that is the reason it's not working. Let's execute that. Oh, now it's working smoothly again. Yeah, so we had a wrong access of the indices here. So it's working well again. So let's just keep the current modeling as it is because it's working. And right now we have the entire environment which is being drawn. And now the difference is that, let's have a look at the application again. We are still drawing cells. We're still drawing cells. And we were drawing cells already at the beginning of this episode. However, the difference now is that at the beginning of the episode, we were just plainly drawing cells, which was just coloring pixels at coordinates without actually knowing what that means. But now coloring cells means we're actually placing cells in the background, in the back-end model, and then we're drawing the entire back-end model. So now we have a back-end model, and based on that, we can continue, or we can calculate the simulation. So this is very important. This is a big difference between just drawing something and actually modeling something, you know? Yeah, okay. So this is what we've done so far. What is the next step? I am aware that we are only drawing solids here. All the other cells should be of state water, because solid cells are white. Yeah, if I press the spacebar, I am actually placing water cells, because that's what we implemented earlier, but we're not seeing anything. And the reason for that is we are placing cells with a fill level that is empty. So we can actually, let's just do a fill level of 30%. So this is our solid, and now let me press the spacebar and see. Okay, and this seems to be working. So now we are filling 30% filled water cells. And yeah, I hope you can see it. Maybe let's make the cell size a bit bigger for in the meantime, just for the time we're troubleshooting things here. Compile it again. Why is this cell white now? Oh no, something happened. Anyways, let's ignore that one white cell there, however that got there. So we are filling the solids, and pressing spacebar, we're filling water cells with a 30% fill level. So that is good. I have no idea where that one filled cell came from. Let me just check if it happens in the other cases as well. No, nothing here. So that is weird. Wait, we have to find out what this is. No filled cells here. But if we do cell size of 40, why is there one filled cell when we do a cell size of 40? And we can't even override it with water. What is going on there? What happens with the cell size of 50? Nothing. Maybe this is a problem that comes from some calculation issue, because I'm not sure, maybe the screen width is not divisible by 40, so something is calculated wrongly. No idea. Let's just stick to a cell size of 10. No, 20. 20 was better. We can switch over to 10 later. But for the troubleshooting, let's do 10. Okay. So that is our current state. I would also like to check the fill level. How a fill level of, let's say, 80% looks like, just to make sure that this is working. Yeah, that is 80%. You can not really see the gap because the line is almost touching it, but this is 80%. This is properly done. Okay, so if we place a water cell, then the fill level should be 1. if this is a solid cell, the fill level is ignored, so it's not, yeah, it's not of importance. Okay, next step. Now that we fill water cells and solid cells, should be deleting cells. So how do we delete cells? What is a good behavior for the user? Maybe if the user clicks a cell that is already drawn, then it should be deleted. But if you want to draw a lot of things in one place, then this is not good. There should be a delete mode. Let's introduce a delete mode, and that is int delete mode, and in delete mode, if delete mode is active, and we activate that delete mode by pressing a key down. So we can extend it down here. So if the key is, let's say, SDLK, for example, X, or let's do backspace. Backspace is always deleting. If we press backspace, then we enter, or we toggle delete mode. And if the delete mode is active, and if we press the mouse, if we cause a mouse event here, then if delete mode is active, then we place empty cells into, we should probably do it here. If the delete mode is active, then the cell type that we're going to do, then the current type is going to be it's actually going to be water, because deleting is practically writing an empty water cell. And these are valid at all times, so we can keep them here. The coordinates are always valid. And then we might have to introduce a fill level. Fill level is equal to, if delete mode is active, then it's going to be 1. Then it's going to be 0, else it's going to be 1. And here we pass on the fill level. Let's see if that works. So this is our bucket. I press the spacebar. Water is occurring, or is appearing. And now I press the spacebar again. We draw more solids. That is good. And now I press backspace, and I am deleting cells. So yeah, perfect. Awesome. Awesome. Perfect. Okay. Now we have, and we're not just deleting cells in the pixels in the graphics, we're actually deleting and re-initializing them practically in the model that underlies the entire simulation. And yeah, let's just figure out what to do next. The next step, and at this point, I would say we are ready to actually implement the water simulation itself. Because now we have an underlying model, we can calculate the simulation steps. And maybe let's do one stupid simple simulation step that is going to be water dropping down. So we place the cells and we draw the environment here. Then we draw the grid. Before drawing the environment and after placing cells and processing all the events, we need to perform the simulation steps. And how do we do that? We perform the simulation step purely based on the environment, which is the backend model. And that is what I was talking about the entire time. So let's create a method simulation step on the environment. And then we're going to go up here and create a new method, void simulation step. And it receives the struct cell environment that is of size rows by columns. Oops. And inside the simulation step, let's just do the first rule. Water should drop to the cell below. And we first have to loop over all the cells for int I is equal to 0, I smaller than rows by columns, I plus plus. The cell that we're accessing is the current cell. And that is the environment. At I. Now, to simulate the water, the cell also has to know about the cells around it and in the neighborhood practically. So I'm thinking how we should do that right here. Okay, we iterate over every single cell. Maybe we need to do a nested loop again, just to be able to properly access all the cells in the neighborhood. J smaller than columns, and then J plus plus. Oops. So now we retrieve the current cell, and the index of that cell is J plus columns multiplied by I. That is the current cell. And let's also get the cell below. And we can only get the cell below if the current if the I index, if the current row is not the bottommost row. So if I is smaller than rows. Probably -1, because we have to be 1 above the bottom row. So if we are in any row above the bottom row, then water can fall down. And to do that, we have to retrieve the cell below, and we can retrieve it from the environment using the right coordinates. So let's just call the environment at the same column, but at I multiplied, multiplied with I minus, +1, because we're getting the cell below. So that is the cell below. And now how do we transfer the water from the current cell to the cell below? We might have to... Well, now it gets tricky. If the cell below is completely empty, the current cell can drop its entire water content into the cell below. However, if the cell below contains water, then this does not work. So let's create a double fill transfer, or transferable fill, and that is the And the transferable fill is the cell below dot fill. Was it fill level? I think it was fill level. So we get the fill level of the cell below. Then we subtract 1 minus that to get the free space. And then we transferable fill. So that is the free space in the cell below right now. For example, the cell below has a 50% fill, but the cell above has a 100% fill. Then 50% should drop down, but 50% should stay in the cell above. Let's call this free space below. And then we need a double retain fill current. Oh, this is a mess. And the retained fill is the free space below minus the current cell dot fill level. What did I do? Current cell dot fill level minus free space below. And if this is smaller than 0, then the retained fill is of course 0, and else it is the current cell dot fill level minus the free space below. I'm not sure if that works at all. And also we have to calculate the entire simulation step in a new struct cell environment copy that is of size rows by columns. And then we have to write the cell state of the current cell into that copy, because we have to simulate one step at a time for the entire grid, and we can't just do cells individually. The environment copy, then we do environment copy at j plus columns multiplied with I is equal to current cell who for sure this is not going to work. What do we do with the cell below? We also determine that we have to update the cell below. This is Is there an easier way to do this? If the current cell contains water, then the water in the next step is going to be oh my god. Maybe we have to create a flows matrix that contains all the flows between the different cells, and then we have to apply it to the environment. Water can fall down. We might have to model flows as well, because we're dealing with cells. They have a fill level, and from this steady state we have to derive a struct cell flow, and that contains the flow in all directions. So flow left, then there's a flow right, then there's a flow up, and then there's a flow double. And in each simulation step we calculate a flow down, I mean. In each simulation step we calculate the flows for each cell, and then we apply it in the after the flows have been calculated. So yeah, this is really tricky. Where did we... yeah, right here. So we have an environment copy, then we have also a struct cell flow flows, that is an array of size rows by columns. Maybe let's keep it a bit more simple. Let's keep it very stupid simple for this episode. We can do it. We can do the best fluid simulation logic in the later on. But I just want to see that water can actually fall down, and water can fall down if there is no water below. Yeah, if there's no water below, then water will fall down. End of story. I know this is not true, depending on the fill level below, depending on the solids below, whatever, but let's just keep it simple for now. So water can fall down, and so here we're checking whether there is even space below. Should we delete all of that? Yes, let's delete all of that. And if there is space below, then flows at j plus columns multiplied by I is... Oh, we probably have to initialize the flows first. Let's just quickly do that. I know this is a performance problem right here, but I just want to prove a point for now. We can optimize everything later. So the flows at this position are struct cell flow, and then we pass on the left flow, the right flow, the up flow, and the down flow. Then water can fall down. This means here we say the flows down flow. What was it called? Flow down. Flow down is going to be equal to 1. Can we manipulate an array index like that? Incompatible types when assigning struct cell flow from... yeah, of course. And while looping over this entire environment, we also copy the environment. No, we don't. We don't need to copy the environment. Maybe we don't need the environment copy at all. And then we apply the flows at the end of the simulation steps. At the end of the simulation step, we apply the flows using another loop. So we do for... Maybe we can just copy this loop here. And here we can say environment at index j plus columns multiplied with I is equal to the previous value at this no, let's do this. struct cell updated cell is equal to, let's just get the environment at j plus columns multiplied by I. So right now we're just retrieving the cell value as it is without modification. And then we have to apply the flow. And of course I have to do a nested loop if I access this by index or by row and column index. So the updated cell is updated as follow, updated cell dot fill level and here we set the flows. Oh. Not straightforward, definitely not straightforward, because we can't just set any value from the flow because the flows matrix is holding all the outflows from the cell. But here, for a specific cell, if we want to update it, we need to know how much is flowing in and how much is flowing out. Oof, this is annoying. Columns multiplied by I. So how much is flowing into this cell? We don't know that. We would have to get all the flows from all the neighbors. So flows at, first let's do the outflow. Flows at this, and then we have a oh, I'm stuck. I'm a bit stuck right now. So let me just draw a new picture here. We have cells. Why is it not drawing? Huh? My paint is broken. Ah, now it's working. Okay. We have a grid. the grid has fill levels right now. So this is a fill level. Now to determine how that fill changes, we would have to interface with the neighboring cells. So we would need to know how much flows to the left and how much flows in from the left. That is practically the delta flow at this border. Maybe we have to model these borders right here, the flow states at the borders. But still, I would just like to see water falling down for now. So what if we just do updated cell, and the updated cell is no. We determine here that water can fall down. Then we need to determine in the cell below that water from the cell above is flowing in. So if for any row that is bigger than the first row, because the first row has no row above, for this row we have to check, is water flowing into the current cell? So we do the following. We retrieve the cell value and we call updated cell.fill level, and we increment it by the cell above. So we get the environment at j plus columns multiplied by I minus 1, that is the cell above. And we get from the cell above the flow down. But now that the cell above is flowing down, we need to empty the cell above. So let's also retrieve the cell above. Cell above is equal to, and to pretty much this piece of code. Oops. This is the cell above. And then we can also change this here, right here, to cell above flow down, and the cell above fill level decrements by the cell above's flow down. This is really not simple. We have to... Well, last time we implemented something using cellular automata, it was the game of life. And the game of life is pretty much, if the cell to the right is filled, then do this. If there are 3 neighboring cells filled, then do this, etc. So it's simple rules. But here we have the state of the entire matrix, and then we have flows between the different cells. So this is not binary. This is harder. We have to think a bit more, but it's definitely fun. So let's see what the compilation error is. I missed a semicolon somewhere. Probably it's... Well, let's have a look where I missed it. Line 118. Struct cell has no member flow down. No missed semicolon. Why? Flow down. But we have to get the cell flows. Struct cell flow, cell above flow is equal to flows j plus columns multiplied by I minus 1 and then we access the cell above flow. Let me compile that. Of course, there's still an error somewhere in line 34. What is the error here? There's a missing semicolon after the struct. Now it compiles. So this is a surface. This is the water. It's not flowing down. Why is it not flowing down? So we do the simulation step on the environment. And here we update the we're actually updating the cells, I would say. Why is the simulation not running? I would expect it to at least do something. For example, some filled values should, or some filled cells should vanish. So something is a bit off. What is wrong? Updated cell fill level. Cell above not fill level. I think I'm just manipulating the some copied values here, but not the actual environment probably. We are retrieving the values from the environment. Are these still, if we manipulate those values, are they still manipulating the entries in the array? I'm not sure about that. is it possible to let's remove all these structures just to make sure that we are properly doing things. So the fill level at environment j plus columns multiplied by I is incremented by the cell above flow, which is that. Flow down. And the cell above's fill level is environment at j plus columns multiplied by I minus 1. Why am I even doing all of this? Let's see if something happens now. Oh, what's that? Oh my god. So we have a self-filling water tank. Yeah, great. Which is definitely not what I want. What's going on there? Here we say that the flow down of a specific cell is 1. Why? It should only be 1 if there is even a value, if it even contains water. So if the environment at j plus columns multiplied by I is, if the fill level is unequal 0, yes, I know this is not going to be 100% correct, but I just want to see water flowing down and not some weird behavior, weird unspecified behavior. Okay. Oh, wow. Ooh, awesome. I don't know why I am drawing solids and water at the same time, but this is a start. This is a good start. Okay, water can fall down. Good. Wait, let me just do another experiment here. So. The problem is I'm drawing solids. If I draw only water, then we will have this watery simulation, although it's not really flowing yet. We're just handling the downflow part. But if I'm drawing solids, the solids still create a downflow here because we are just checking that the fill level is something. And we have to make sure that the fill level of a solid is considered 0. Yeah, because, it just makes no sense otherwise. So the current type, so when we set a cell, we create a new cell here, and we need to set the fill level no, that's not the source of the issue. The source of the issue is that when we simulate the environment, we should simulate it only for water cells. So water can fall down, yes, but not solids, right? So the current cell, if current cell dot type is equal to solid type and we're not in the last row, then okay. Oh no. Yeah, okay. This, of course, the cell must be water type. Okay, now we're drawing solids, and I press the spacebar. Now we're drawing water. So this is already doing something, or although it's not a proper flow, as you can see. And if we, oh, okay, something is happening here as well. We need to, yeah, this is really buggy. Okay, but I am fine with the state as it is right now. So we have this very simplistic water simulation or fluid simulation, but of course this is not, this is not what it should be yet, but it is a good starting point. And in the next video, if you're interested, we will finish the logic, or we will continue with the logic. I don't know how long it takes to do a proper water simulation. Yeah, so let me just show you again how it looks like right now. So this is our current state. We're basically just stacking blocks. We don't have a proper flow. Yeah, okay. See you next time. Please leave a like if you enjoyed this and subscribe, because we will keep coding this until it works perfectly fine. And then we will make the cell size so small that we will have a really realistic water simulation. This is my goal on this. Okay, so then see you next time. Bye.